Sorry, guys. There's a call that came in. There are people that I'm supposed to coordinate next week, so it's been heavy work, ALX, and that 3 activities for this week and next week. So let us start. Are you able to see basic concept of statistics?
Yes, I can see.
Okay, yeah. So this document has been prepared by Jebet, so I'll try to go through it, why I do understand and explain. And then these formulas are the ones that give me a headache each and every time. So let me just try and explain what I know and try to explain those formulas, but they're being prepared by Jebet. So Jebet, if I go wrong, you should also assist me. So the basic concept that we're going to look at today is population, sample, parameter, statistic, and statistics, and then sampling error. So we start with population. And when you talk about population, we mean every unit or object in a study. So that is the population. Like, for example, the population of Kenya. And then a sample will be a statistically significant portion of the population. It has to be a representative. And one of the examples that I can share is that we do have some survey firms in Kenya that do like surveys on even who will win the elections or something that is going on. And because they cannot be able like to ask each and every Kenyan, they usually like do a sample. They just pick a sample, maybe from each and every county within Kenya. And this sample needs like to be a representative of the entire population. And basically, the rule of thumb usually says that at least if you have like 30 and above, if it's a normal distribution, and then you have 30 and above people or items that you're going to research on, then that is a good sample. Then a parameter is a summary number that describes the whole population, e.g., averages and proportion. So that is the parameter. For example, even we can look at a mean of maybe a certain population. For example, we can be looking at the ages of maybe people who range between 14 years and 24 years. So that the mean age, that can also be a parameter, averages, proportion, and all that. And then a statistic is a measure drawn from the sample, used as an estimate for the population parameters. A statistic, kindly Jebet explain, I've forgotten statistics. Let me mute for a minute.
Basically, a statistic is just anything that is calculated from a sample. Now, for example, if we are taking, let's say, ALX students in Nairobi, and then now we pick a sample of 100, the people usually attend the morning sessions, and we take them to represent the whole ALX learners. So any calculation that we get from the session, from the morning, from the 100, that will represent the statistic. And if we're calculating the mean of the sample, that's a statistic. If you're calculating a proportion of the sample, that's a statistic. And it represents, like we can use it to estimate the population. Now we can say that of the people that come to ALX, their ages, average age is 30. And that was based on the sample. But now we are going to assume it will represent the whole population.
Okay, thank you so much, Jebet. I don't know if anybody has a question on the same. Okay, no question. Then we have statistics, and these are accounts from sample data. Statistics, a collection of methods used to collect, analyze, and draw conclusions from a sample data, like the surveys that you usually have. Those are like a collection of methods. Sometimes you carry out surveys. Sometimes you do what we call KIIs, key informant interviews. We also have like interview themselves one-on-one. So from that one, from such methods, we use them to collect data. And then from that data, we can be able to analyze it and then draw conclusions that maybe we can infer to the entire population in what we call inferential statistics. And I believe Jebet will tackle the parameter and the statistics and the sample statistics. So the difference between the population parameter and the sample statistics. For example, if we get the mean of the entire population and then the mean of the sample, the difference, that is what we call the sampling error. So up to there about the basic concept of statistics. Does anybody have a question? And I'm hoping that I'm not moving very fast. Sometimes I move very fast. Am I moving very fast, Eve?
No, I think in case of any questions or comments, guys can raise their hands and speak up.
Okay, thank you for that.
Sorry,
then you have,
after the session, you could also share the same documents. Thank you.
Thank you. Okay, thank you so much. Then we do have types of statistics. We have quantitative analysis and qualitative analysis. In terms of quantitative analysis, is anything that has to do with numerical calculations like aggregates and models, statistics and inferential statistics. In descriptive statistics is a direct description of the data. So just like describing the data. People with ages 0 to 5, and every information that can be easily seen from the data, like for the graph that we did do last time when Nehemiah was taking us through, there was some graph statistics. Then we do have inferential statistics I explained earlier. For example, when we carry out a survey and then we come up, like, sorry for people who do not live in Kenya, but let me use the Kenyan scenario. Before every elections in Kenya, we have so many survey firms that usually carry out studies, and then they start telling us that Kenyans are saying this is the person that they will vote for. But truth be told, I have never been approached by any of those organizations or firms. So other Kenyans are speaking on behalf of myself, and that is what we call inferential statistics. Then you have qualitative analysis, handles data for which no natural numerical scale can be applied to. Hey, Jebet, we have used bigger terms, because qualitative analysis, from the way I've learned and understood, is not something that I'm reading. Do you mind explaining that sentence? That's Jebet.
Like, no gender seats female and male.
Yes.
That's a textual data, right? But we can still apply numeric. Like, we can code it in binary, right? So the qualitative analysis, like, we cannot code it in any way. Mm-hmm. We cannot put numbers anywhere. So it's just like your opinion on how, again, then we're going to be biased about Nairobi. So let's say we are describing the city Nairobi. So you're going to say it has trees. Me, I'm going to say it has a lot of roads. You see, we cannot quantify that data in numbers.
Okay, thank you so much for that. I hope I'm not cutting you short a bit. Okay, thank you so much for that. And let me give another example about qualitative that I've seen and people use is about, just the way Jebet has explained. When people have collected some data, they usually, qualitative data, they usually go sit down and do something that, I don't know how they call it, but they usually say that they're coming up with a theme. maybe because people have said that Nairobi, so they're able to analyze that data. I do understand that you have softwares like NVivo that does that, but qualitative analysis, maybe someone who has experience will also educate us on the same. So thank you so much for that.
Ibrahim, now you see what you're talking about is actually a branch of qualitative analysis called thematic analysis. Yeah.
Thank you. I've learned something new. Okay. So that was basic concept of statistics. Now we go to descriptive statistics. Let me use my hand to, and that's where we have the mean, the mode, and the median. The second have measures of variation, that is how spread out the data is, that is one which the distribution, that is frequency of each value. So those are topics under descriptive statistics. And a sample mean is thought to be true. Jolene is asking, what are we tunaongelelea nini? Can somebody explain to her what we are doing? Can somebody come up and I've started with basic concept of statistics. So we explained what a population is, what a sample is, what a parameter is, what a statistic is. What statistics is and about descriptive statistics. I don't know if you missed any part on all those. Are we together, Jolene? Okay. Let me just go ahead. We are on descriptive statistic, and I was talking about a sample mean. A sample mean is thought to be true estimate of the population. And then the sample mean equals to the population mean. Hey, Jebet, what you have written here, I'm trying to read and explain at the same time. So a sample mean is thought to be true estimate of the population. Are we talking about hypothesis here, Jebet? Is that what you like? Something that you envision to explain here?
We're not talking about hypothesis. I don't know. When you're calculating the mean under normal situations, it's the sum of everything over n, right?
Yeah.
When you're calculating the sample mean, it's still the same formula.
But you minus.
It's still over n.
Still over n, but you need to minus 1.
No, you don't minus 1 when you're calculating mean.
When you're calculating the population mean or the sample mean?
The sample mean.
The sample mean. Yeah, still the same, yeah.
No, you don't minus when you're calculating the sample mean. So that's why now it's thought to be a true, unbiased estimate.
So that sample mean will be used to infer the population mean, to say that this is thought to be a true estimation of the population mean.
Yes.
But it needs to be tested later on, or if that is true from the sample. I don't know. Anybody good in statistics? Then we have just said, for variance, we lose degree of freedom when using the sample variance. What
where the n-1 comes in.
The -1 comes in. Oh, I'm just hoping that I'm explaining the right things. because I'm reading, thinking, and explaining. So,
Yeah, I think so.
am I correct, Jebet, the file owner?
Yeah, I think you're correct.
Okay. So, no certainty. We are sure of the values since it's coming directly from the data at hand. Explain that kindly, Jabet. You know, you have written very short notes. So, what do you mean by that statement?
No uncertainty, like we are sure of what we are seeing. See, in the descriptive statistics, we are only writing whatever we're observing from the data.
Yeah.
So we are saying, like, there's no uncertainty. If we are saying that the sample mean is 100, it is truly 100 because it's something that we can see. If we are saying that the distribution, we have more males than females, it's what we are seeing.
Okay, thank you so much for that. Thank you so much for that. So here are where the tasks begin, where we need to import some Python modules for us to work with them. And the first one is the Python pandas, and then you have the NumPy. So from this code that has been written here by Jebet, we're going to import pandas as PD and NumPy as NP. So let me try and run that code and see if it works. Has it even worked? Yep, I'm hoping it has worked. Then there's a code here. From this code, I do understand that we are importing a .csv file by the name tips, and we are storing that in a variable known as df, or data frame if you so wish. Then that is from this function here. Then we are going to select a sample of 100 from that data set known as tips. Once you select that, we are going to print the population data, and then we're just going to use the function known as head. So head gives us, I think, 10. This other function here, I'm sorry, I don't know what it tells, or it will draw a line on the same. Then you're also going to print the sample data so that we can see the population and the sample data. Yeah. So from the population, you can see we have, I like calling them variables. These like the column headers. So forgive me if I use the word variables. So we have the total underscore bill. We have the tip. We have the sex. We have smoker, whether you smoke or no. Then you have day of the week. Then you have time, if it's dinner or any other time. Then you have size. So from the sample data, what the sample has been able to pick, you can see here you have numbers like number 1 up to, I've not looked at the data, I don't know where it ends, but it seems like it's more than 232. So from that sample, this function here that picks a sample of 100 has given us this data. And the first, the top 5, we can see we have like index 69, 115, 79, 215, and 232. These are numbers. So it has kind of like selected randomly from that data and then gave us this data. So we still have the total bill, the tip, the sex, the smoker, the day, time, and size. So descriptive statistics, this function, we want to describe that. Are we describing the sample here? No, this is not the sample. We are describing the population here. You can see the DF is the population. So we are going to describe that population. And because it will, summary statistics will give us, I had something, you are calling them 7, what? 1, 2, 3, 4, 5, 6, 7. Yeah, 7, those summary statistics. So for the tip, for the total bill, tip and size, you can see we are having a count of 244. That means in that data set, we have 244 rows. Then for the total bill, the mean is 19. For the tip, the mean is 2. For the size, the mean is 2, but 2 point something, 2 point something. They are not rounded off. Then we do have the standard deviation for each variable. We have the minimum value in those columns, each column. Like the minimum value in the total bill column is 3.07. The minimum value in the tip is 1, and the minimum value in the size is 1. So the first 25% of that data set, that number lies at 1322. The middle number at 50%, you have 1722. Then at the 75th percentile, 75%, you can also see that. Then the maximum values we also have, like for the tip, the minimum value was 3, the maximum is 50. For the tip, the minimum is 1, the maximum is 10. And for the size, the minimum is 1 and the maximum is 6.
Hey, Brian, I see you has raised his hand.
Sorry?
Someone has raised his hand, John, I think.
I cannot see that. Warutere, John?
Oh, I wanted to ask, for this sample, is it picked at random or is there a criteria for picking a sample?
No. I think this formula here for picking that sample from Python, I don't know how it works in the back end, but I believe it's picked randomly. I don't, because if you are human being, then maybe could be doing things to do like cluster sampling, snowball. But for Python, I don't know. Maybe if Nehemiah, you can explain how it picks this sample. Because for me, I think it's random.
Ibrahim?
Yes?
There are different functions for picking a sample, but now this one you see it's not random, so it's going to pick randomly. If you wanted to do a cluster sampling, there's a function for that. If you wanted to do a stratified sampling, you would do that as well. So it's what you define.
It's what you define.
Yeah. But not this one for the sample. This one, like the default is random.
Yeah, because I've just said dot random, and then I was trying to look at where
there's another one that goes dot random. I'm sorry.
Okay, so the default, when you just say dot sample in Python, default is random. It does random sampling in Python.
Yes.
Right?
Yes.
Okay, thank you so much for that clarification. So there's a question. I can just hear this laptop. Thank you. Okay, so for the measures of central tendency, and we say that there are 3. That is the mode, the mean, and the median. From this file here, we are going to calculate the mode of the tip. You can see the tip is here, not the bill. The tip, this middle column here. So the formula for doing that, we will take our variable, which is df, or the data frame. Then this is like slicing. We are picking that column known as the tip. Then we want it to find the mode. This is the mode function. And like Nehemiah has been explaining to us for so long, when we write a function, we need like to put it into a bracket. So this is what this function will do. The second function will look for the mean and is the mean of the population also. And then np.median will look for the median, and here we are using NumPy. It will look for the median of the tip, this here, this column here. So everything that we run and those that will be running will be checking on this column known as the tip. So let me try and explain this other one. And then from there we look at the variance of that tip, and then the standard deviation of that tip. And remember here, we are not using the sample because the sample is something else. Here we're using the entire population. So let me try and run this code and see what it gives us. So this is 1.23. 1.38. Jebet, what is it like printing out? Is it printing
The
out?
standard deviations, you've not printed the other. It's only,
Sorry?
in Python, it only prints out the last function.
The last
if you
two.
want the others, you will have to use a print function.
So this is standard deviation alone.
Yeah.
Okay. So should we print the others, or what do you think?
I don't know if there is need be. The reason why I wrote this is because I just wanted you to know that there's another way you can find the mean if you don't want to use the describe function.
Mm-hmm. Okay, thank you so much, Jebet, for that. If anybody has a question or wants something to be done, just alert me. I'm trying to explain, then Jebet will do the others. So the formula for the population variance, you can see it. I cannot cram it. And the sample variance, you can also see it. I don't know, is there any point in time when we will be using these formulas manually? I don't think so. So there's another line of code here that says descriptive statistics of the sample. Then measures of central tendency are calculated in the same manner as that of the population. So the same manner that these have been calculated, the mean, the mode, and the median, is the same manner that we shall calculate the measures of central tendency. So there's a line of code here that has been written, and the first one you're going to do is variance and standard deviation. We use n-1. N is the total number of the sample. Then we minus 1 to get the degrees of freedom. And when you're doing variance here of a sample, you can see here you have df underscore sample. Then in that variance function, we will do DDOF equals to 1, meaning that we are minusing 1, like this one here. We are minusing 1 because we are looking for the variance of a sample, unlike the variance of the entire population, as you can see here. Nothing has been used like the degrees of freedom, the DDOF. And then variance, that is only for the variance. So this function here will calculate the variance of the sample. And this function here will calculate the variance of the sample, but also print it. But this is the function here. This inside function will calculate the variance, the standard deviation of the sample. That's why you have seen we have DDOF equals to 1. Sorry for that. I don't want this function to move. This one equals to 1 because we are using a sample. And this is the formula for calculating the standard deviation, which is the same as this one. .std, standard deviation, .var, variance. So, but standard deviation, it will print. So we shall compare this standard deviation here with the population standard deviation here. after it has printed. Maybe try to already even run. Then alternatively, we can use the statistics module. So apart from doing these, apart just like from using the pandas and the pandas and the numpy function, we can also import the statistics, the import statistics. I'm just hoping that I'm saying the right things. I've not read. So we're having statistics.p variance to calculate the variance of the population here. Then you have statistics.variance to calculate the variance of the sample, and this function look very different. Then we have statistics.p st-def, that is the standard deviation, and then we have statistics.st standard deviation. From my understanding is that the P stands for population in this, yeah, and then here maybe S stands for the variance. Jebet will explain to us. So for us, what does that mean? So as we can see, the first one that it has printed here is the sample, is the sample standard deviation, which is this one. And then what else has it printed? The last one here, I think it has printed this one, which is the standard deviation of the sample using the statistics module, something of the sort. So if you compare the sample standard deviation with the population standard deviation, we see that the sample standard deviation is a bit higher than the population standard deviation. Yeah. So mine was to reach there, Jebet. Or do you want me to continue with these things? I have not read anything. But those ones, at least, I thought like I can try and explain and for people to understand.
Ibrahim, can I
Yes.
ask a question? What is the DDOF stand for?
I think that's the degrees of freedom.
Oh,
Because when you are calculating the variance of a sample, we take the total number of that sample, then we minus 1 to get the degrees of freedom. That is why 1 has been used in these two, because here is a sample that we are using, the DF sample here, and also here is a sample. That's why they are not appearing here, because here the DF is the entire population from this .csv file. And then the sample is picked from here and stored in a variable known as the df.sample.
Oh, Ambale, what does tip mean?
Tip, I think is just I like calling them variable. That's what I mean. I don't know how. For example, if you're having an Excel.
Oh, I get it. I have now seen.
You have understood, huh?
Yes.
Yeah. So like we were calculating all those calculations. We are calculating those calculations on this column. Yep. Let me try and check something here. We have the summary statistics give us the mean for this tip. And the mean is 2.99 something. And the mean that we have calculated here let me just... The problem that I have is printing Python functions. I have a very big problem. I don't know when I will learn to print these functions. I just don't know. I hope this one will work. Let me check on something here. So the mean, sorry. I'm printing the mod, guys, and are not even telling me that I'm printing something that I don't want to see. Let me print the mean. I just want to compare something. We are in the learning process. Yeah, let me just try. So the mean here, this is the mean. This is the second variable that has been. This is the mean. So I'm trying to compare this mean calculated by Python with this mean also calculated by Python. So they're kind of the same. Let me see. Yeah. 2.99827. Yeah, they're almost the same. Okay, fine. Thank you. Yeah. So Jebet, back to you for inferential statistics, if you don't mind.
Yeah, it's okay.
Thank you. Any question that maybe somebody has for me before I stop sharing my screen?
Yes, I have a question.
Yes.
So when we are calculating variance and standard deviation, it means we are calculating how spread out the maybe the data is from the mean for both. So my question is, what's the difference, or what measure is the most accurate? What measure is the most accurate, and what's the difference between variance and standard deviation, since they both are calculating how spread out the numbers are from the mean?
Maybe I leave it to someone who is that friend of ours, Ian. He seems to be very good in statistics. Maybe he can try and explain that. But let me also try and explain. From my understanding is that the standard deviation, I've forgotten everything that I learned. It's been many years. We usually multiply, square those after. This is like the mean is 5. Then we go and minus those figures from the mean, and then we square them. So we get the standard deviation. But for me, I don't think that I'm in a position to tell you which is the best variable to use, whether to use the variance or the standard deviation. Maybe somebody good in statistics can tell us.
Okay, can I just help a bit?
Yes.
Mathematically, standard deviation and variance have this relationship. For instance, if you have your result as 2 for standard and 4 for standard deviation, and you want to get the variance, you just say 4 times 4. It will give you the variance. What it means is standard deviation is the square root of variance. So if you have 16, for instance, as your variance, and you want to get standard deviation, you just take the square root of the 16, which will give you 4. That will be the standard deviation. I think that's it about standard deviation and variance.
Okay, thank you so much. I believe that was Anthony, if I'm not wrong. But
That's
also
Thomas. That's Thomas.
Oh, Thomas. Okay, thank you so much, Thomas. And maybe also, yes, go ahead kindly.
Okay, so this is Anthony speaking.
Yes.
Now, just to continue from where Thomas stopped, when we're calculating variance, we normally square the difference between the mean and each of the variables and each of the data points. Mm-hmm. So to account for that squaring is why we need to refactor back to standard deviation. So that the number does not get too big when you eventually get your variance. You know, each of the, when you're calculating variance, you're minusing x minus the mean. You're minusing from x, and you're squaring it. Mm-hmm. So that's when you're getting the variance. Now, so that the number doesn't get too big, that's when you now reduce back to standard division. So it depends on your calculation and on your preference. So basically, they are the same thing. It's just there as like Thomas has said, the standard deviation is the square root of the variance. So that you reduce back the number to a more standard measure. Thank you.
And just maybe to ask because Lorraine did ask about which one is the best, because maybe there are some rules that maybe tells us which one is the best to use.
Yeah.
Okay.
Okay.
Let me see if I can answer that a bit, right?
Okay, Ray, go ahead, and then the person, I don't know. Yeah.
Okay, for variance, basically, right? Variance is the square root of standard deviation. So it's usually appropriate when you're comparing the mean across different data sets, right? So since each data set may not have the same units, right? So it would be appropriate to use something that would correct for this, and you can see the spread of the mean across various data sets. But if you are usually working within a single data set where the units are the same, then standard deviation is more appropriate for that. That's just what I wanted to mention. The other person can continue.
Yes, there was someone else who wanted to speak. Kindly go ahead. Can't see your name. Yeah, there was someone else who wanted to speak. Just speak, just unmute and speak kindly.
Yeah, Ibrahim.
Yes.
Just to answer the Lorraine question directly, standard deviation is basically the square root of the variance, and it's the most appropriate, or the most is the best one that will give us the better vision, the better description, or a clearer picture of how spread our data set is, from one point to another. Because it can be able to tell us how much different data points are varying from our mean. Since you remember that we say standard deviation is the square root of variance. I want to use an example of something like, okay, for you to get, I'm looking forward to make it a bit more clearer. But I can say this, now that you know that the standard deviation is the square root of variance, it means that we are able to get a very clear picture on how spread our data is, in relation to the mean and other data points, since it makes it easier for people to visualize and easily understand how spread our data is, whereas the variance, which gives us the average square differences of different data set, of the data set that you have. I want to take an example of, let's say you are going from CBD, CBD to, let's say, point X, and point X is like 2 kilometers. Now that one is standard deviation. And if you're going from CBD to point Y, and point Y is like 4 kilometers, that is something that I can describe as a variance. So if you look at it clearly, our standard deviation, which is point X, is more closer to CBD than our variance, which is 4 kilometers. So that's why we say standard deviation is the square root of variance. I don't know whether that is clear or...
There was something that Nehemiah one day opened. What is that thing? Do you call it digital whiteboard or what? What is it called? Digital whiteboard or what? Nehemiah, kindly, if you are there. Don't know what digital. You Google something.
Let me help.
Sorry.
Because I just wanted like to draw when Ian was explaining. I wanted like to draw so that people could understand what Ian was
Ibrahim.
talking about.
Ibrahim.
Yes.
You see down at your screen where there's the chat icon, then there are the people who are in the meeting, then there are some triangle, square, and a circle.
Here.
Bottom right, I think. Yeah.
Bottom right.
The other one.
Here. Yeah, activities.
Yeah.
Mm-hmm.
Click on that one, then you'll find the board there.
Oh, thank you so much. So what do? I add it?
The whiteboard. No. The whiteboarding.
The whiteboarding. So, sorry. Like here, I click on this one.
Yeah.
Then start the whiteboard. Yeah. Oh, has it started? Okay. Yeah. You can see my screen.
Yeah.
Yeah. I just wanted like to draw what Ian was saying. Like this is the CBD here. So there's a place here, maybe K, which is 2 kilometers, and then there's another place here. Let's call it Y, which is 4 kilometers. This is what I believe, Ian, you are explaining, that this is the CBD here.
Yeah. You can do it better by drawing both of them in the same side.
Oh, in the same side?
Yeah, on the same side, yeah.
This is to erase. I'm hoping so. Oh, yeah.
Yeah, sure.
Let me just try and erase this and then draw it on the same side. So for instance, this is the CBD here. Then 1 point comes to 2 kilometers. Here. And then I'm not a good drawer. So this is what you explained, Ian.
Yeah, sure.
Yeah. Hope people have understood.
This drawing doesn't make us understand well. Please explain it again now. Now that I've seen it.
That deviation, which is point S, usually say standard deviation is the square root of variance. Now if you say the square root of 4 kilometers is 2 kilometers, this is just a hypothetical example.
Mm-hmm.
Yeah, now, if you want a clear picture, it's just a clear picture, but it doesn't mean that it's more accurate than, it doesn't mean that standard deviation is more accurate than variance. But if you want to get the clear picture of how spread our data set is, the best one that we'll use is standard deviation. Since from this hypothetical example here, standard deviation is closer to the mean. This this point.
Maybe this is the mean.
Exactly. Yeah, and it's showing us dispersion, how distributed our data set is. So you find that by using a standard deviation, it will give us a value like 2. You see that 2 is more closer to the mean compared to 4, which is a bit further. Yeah, that is just what I wanted to say. But mark what I'm saying, it doesn't mean that standard deviation is more accurate than variance.
Okay, thank you so much, Ian. Anyone else with a question? I know time is running out and I need to allow.
We have William who has raised his hand. William, you can go ahead.
Yeah, I'd like to request that Ibrahim, you go back to the slide that you are, sorry, not the slide, the notebook that you are using.
This one.
Scroll to where these two formulas.
Mm-hmm.
Now, maybe let me try to explain something about the formulas so that I can't fully say which. Sorry, you've gone ahead.
These formulas,
Yeah, those formulas.
Which one? These ones? These ones here?
No. Just where you were.
These ones?
Where we have the standard population, standard deviation, and the
statistical formulas.
Yeah.
Yeah, these ones here.
No. The ones at the bottom.
Okay, these ones here. These ones here.
Yeah, exactly.
Okay.
So let me just talk about the 8 of them. So you see, these two formulas is a summation, and when I say the summation, suppose we have 5 values like 1, 2, 3, 4, and 5. We'll add the 5 values together. When we add 1 to 5, we get around 15. We divide 15 by 5, we get a mean of 5. Take 1 minus 5, you square that value. You take 2 minus 5, you square that value. You add all those together. Plus square. This
is square. That is square in Python.
Yeah.
Then we take another.
No, I think it's two asterisks.
Oh, 2 asterisks. Yeah. Like that. Huh?
Yeah.
Then 1 minus
2. Sorry. Squared. Plus
we add another one.
Yeah.
3 minus 5. 3 minus 5 squared. Like 4 minus 5.
Had 5 units, or rather, our sample size is 5, and we are trying to calculate the sample size variance. The sample variance. We'll add all those together. That is what that Kasaini in a can. And I is equals to 1 to n. Means it means that you sum all this that you've typed here. Then divide that by 5. When you've done that, you divide it by 4, which means it's if. So when you've done that, that is what you'll get now, like the sample variance, if it's a sample of 5 units. Then when you want now the standard deviation, you'll just take whatever you've gotten from that figure, you square it. Is it? No, you don't square it. You do a square root of it. Then you get the standard deviation. So I don't know which one is its own advantages, and it's applied in different ways, because when you are looking now for the statistic measures like the t-test, like the t-test and the z-test, you now have to employ the standard deviation, and you cannot arrive at the standard deviation before you touch on the variance. So suppose now you've gotten that 30, you can now take for the variance, you take like 30 divided by 4, which is like 30 divided by, you can do like ABCD into bracket, the whole of it divided by, just type.
Let me just copy this into brackets. So this is divide in Python.
Yes.
Will it work? Yeah. So I've done that, divided by 5.
5 minus 1.
Sorry?
Or 5 minus 1, if it's the sample size, we are using a sample.
Oh, so I minus 1 here.
Yes.
Here, like that. Okay.
Now, for that one, now you have the variance. Now, if you want now the standard deviation, you'll take whatever you've gotten there. You can just name it like a variable, say like k is equals to all that you've typed there.
Or this one here.
Yes. K is equals to this. So k is the variance for you to go first. The standard deviation, you can add another. Now for standard deviation, you just take k, square root of k, sorry. The square root of that k. Now you'll have the standard deviation.
Square root in Python. How can I do that in Python? Square root.
Square root.
SQR, I think.
So it's k.sqr or sqr dot something.
No, I'm not sure. I'm not sure about the syntax for square root.
SQR. Let us try
SQRT dot.
Exactly.
K.sqrt. Yep. Okay. Error. Float. It's a float. Why? Mbona inakataa inasema float?
SQRT into K. As in the K should be in the bracket.
Or the K should be in the bracket.
Inside that bracket.
Okay, thank you.
I'm not sure. I'm just.
Still not working. Or we need like to call SQR is in which module? Is it the pandas or the numpy?
Write math.sqrt, you see if it will work. But maybe it might need to include the package.
You'll need to import the math module.
Yeah,
that's what
you can just do an import.
Like that.
So, but just for the sake of time, I hope now
thank you. That's what
it's now clear. So,
and I was asking about calculating K. You know, there is order of precedence in the operations. Is it correct?
I don't know if I have fully comprehended.
Print K and print K.
K is 5. Are you able to see?
Yeah, I can see. Is it supposed to be 5?
No, because it's supposed to be.
Okay, you can put 5 and 1 in a parenthesis.
Exactly.
$7.5.
No, yeah, that's correct because it's 30 divided by 4. So I don't know. The one who asked the question on which one which one is supposed to be used. I can't say you can use variance or you can use square root. Sorry, not square root, but the standard deviation, because both of them are applicable in different ways. And for you to arrive at the standard deviation, you will have to calculate the variance first. So thank you.
Yeah, thank you so much. Whoever was speaking, sorry, I'm not good in catching names. So any other question, or I allow Jebet to talk about inferential statistics? Okay, well, maybe I should stop sharing my screen and then Jebet, you can come on board. Thank you so much, guys, for attending. I hope I've said something constructive and something that is true and not a lie. Not a lie, not angoa, a lie. Yani sijadanganya. For those Nigeria, sijadanganya, meaning I haven't lied. In Kiswahili, you learn Kiswahili by force, by fire.
Ibrahim. Angoa means what in Luo? And
I even don't know. I'm Luya.
and Vin is Kenyan, so he understood whatever you were saying.
Yeah, I'm Luya, but I just hear my Luo friend saying Angoa. So Angoa, as long as it's like that, as long as I've not abused somebody, please. Sorry, guys. Thank you so much.
Oh, thank you for that, guys. So allow me to share my screen. I don't know if you can see my screen.
Yes, you can see it, Jabet.
So again, I'm going to be dependent on your inputs as we go on. Ibrahim had left it here. He was done with this. So just to clarify on this one, when using this module, if you input P before variance, that means you're calculating for the population. But if you do not, it means like the default is for the sample for this particular module. I'm going to be going through the inferential statistics. And as Ibrahim had already said, inferential statistic is simply using the sample to make conclusion about the population parameters. And in doing so, we have the hypothesis testing, we have probability. It's also the basis for predictive analytics, that's regression. And then for causal relationship, like if, let's say, an increase in price of a commodity can be said it is caused by a certain variable. So that means we have to test it to confirm. So to start us off, I'm going to talk about estimation. Estimation is simply the process of calculating a value or a characteristics of the population based on a sample. The reason why we call it estimation is because we cannot be 100% sure that is the exact value. Since we're using a sample, we do not capture everything from the population. So we're just estimating. We can never be like 100% sure that we have captured everything. So that's why we are calling it an estimate. In estimation, we have a point estimate. A point estimate is simply calculating a single value. So for example, I'm calculating mean. I just calculate mean and I get my sample mean to be 20. That will be my estimate for the population. Like I'll just say, population is estimated to be 20. For the interval estimate, you calculate a range of values. And for that range of values, it's like you're calculating the mean, and then now you have a margin of error. So the margin of error can be either plus or minus. An example is when we were doing geography, like not geography, geometry. So when you're drawing, then you're getting your measurements, you're given a margin of error of either plus or minus 1. So it's the same thing. Only that now you have to calculate. So let's say, if we say my margin of error is 2 and my mean is 20, so anything between 18 and 22 is a valid answer. So that is for the interval estimate. And for the confidence interval, it's simply an interval estimate that uses variance in its calculation, as in it takes accounts variance. And you'll hear me talking about the standard error. So standard error is simply the standard deviation. So I guess that's where you can choose to use standard deviation when you needed to calculate maybe hypothesis testing, maybe interval estimates. You'll need to use the standard error, which is simply the standard deviation. Confidence level is the degree of certainty, how much we can be confident that this interval contains the true population parameter. If I'm given like a 95% if I'm saying like I'm 95% confident that the population lies between the population mean lies between 18 and 22, that means I'm giving myself only a 5% chance of making an error. I don't know if we get each other up to there.
Yes.
So here I was just giving an example of a point estimate of the mean, which has just calculated the mean of the tip, the column tip. I don't know why I like that column, but we can calculate for any other column. So me, I went ahead to calculate that one. So here is where I have forgotten a little bit, but I hope I'll remember. If you're calculating the confidence interval of the population mean, it's usually the population mean plus or minus. This whole part here of the formula is simply the margin of error. And here we have Z alpha over 2. Okay, Z alpha is simply, how do I put it? The Z statistic. Who can help me explain that Z alpha?
Sorry, Jebet, you're saying to explain what?
The Z statistic here in this formula over here.
Okay, from that formula, I think when you want to get the alpha, and the alpha is, what is it? Is the upper bound or the lower bound? So from my understanding, we shall use the Z table. And then because, for example, if we say that we are 95% confidence, then we shall take like that 95% divided by 95% is basic, divided by 100 is basically 0.95, if I'm not wrong. Then we take 1 minus that one, right? To get that alpha, that thing that is over 2. You see there's something there, and then 2 below it. I think to get that variable, we take 1 minus the confidence, the percentage of the confidence level. Then we multiply, but it's very tiny. Cannot be able to see, despite having specs. Pray for us, people who are born with not seeing very clearly. Yeah. So from this formula, we have the X bar is the sample mean, then it's plus or minus the Z score. Then you're having the alpha over 2. I've told you how to calculate the alpha. Then you're multiplying by the standard deviation. That's the formula for standard deviation. Yeah, standard deviation over, we're dividing by the square root of n, and n is the total number in a sample. So from this formula, when we say, when we now use the addition, then we shall get the upper bound of the confidence interval, let's say 56. Then, for example, if we now use the subtraction, then we shall get the lower bound, let's say 42. Hope I've explained something.
Yes, Ambale, and maybe to add on to this Z alpha, I think, and then we divide by 2. This means that it's a two-tailed test. So when we have that Cabell,
aliona hana time.
Nemo, we are listening to you.
I'm so sorry. Follow.
So I was saying when we have that bell shape, and then our confidence, the 95% is at the middle. So the excluded part is the farthest right and the farthest left. So that's what we are calling the alpha. And if we divide it by 2, it means it's a two-tail, which means that we have both the left side and the right side. So we divide the Z alpha with 2.
Yeah, I think that's right. Thank you. So, does anyone want us to calculate this manually? Because we can, or we just continue.
Mildred, hi.
Hi.
Oh, let me ask. When you're saying you're going to divide by the standard deviation by the square root of the mean, see only same?
What do you mean?
Mean. Isn't that the same as standard error of mean? When you said something about the margin of error.
I said, you see this whole part here. I wish you see this whole part here, Z alpha over 2 times the standard deviation over root n. That all is the margin of error.
Oh, the whole of it is the margin of error.
Whatever I get here, whatever I get here, I can move. If I get 3, I can move 3 steps back from the mean or 3 steps forward from the mean, and that interval now becomes my confidence interval.
Okay, so thank you.
Anyone who still has a question? So I'm assuming the silence means there's no question. So here we're going to calculate the confidence interval and of the tip, that the sample, the tip column of our data set. So what we need to do is first calculate the mean. Here I just sliced the tip and assigned it to a new variable called sample data. And then I went ahead to calculate the mean of that tip, and then the standard error. Standard error is the same as the standard deviation. My degrees of freedom is n minus 1. So n here is going to be the length of that column minus 1. Because now my sample was 100, so I'm assuming here is like 99. My confidence level is 95%, but here is a proportion. And now when calculating, this is the module that we use is the stats. And then the T here stands for T statistics. And then we're calculating the interval. So we need to provide the confidence level, which is here 0.95. We provide the degrees of freedom, which is here. We provide mean, and we provide the standard error, which is also here. And then it will give us the confidence interval. Anyone with a question? So this part of the Z alpha, we're going to see more of it when we'll be talking about the normal distribution, which I think will be tomorrow, because that's where it originates from. There now, here we are going to understand.
Please, can you just mention the difference between the confidence level and the confidence interval?
Yes. Pardon?
Oh, I said, can you mention the difference between the confidence level and the confidence interval?
Also, the confidence interval is an interval, like it's a range of values which contains a possible value for a particular population parameter. So, for example, it's between 18 and 22. So 18, 19, 20, 21, 22. That's the confidence interval. You getting that one? And then now the confidence level is just how certain, like how confident am I that that range that I have will actually contain the true population parameter. I don't know if you get me.
It's okay, it's okay. Thank you.
We move on. So here we now go to probability. Probability is simply the likelihood of an event occurring, like the probability of it raining today. the probability of you falling down today. That's simply probability, like it's a chance of an event occurring. And in probability, we have a random variable. So a random variable is any variable x that can take any value in the sample space. And by sample space, I mean if we take all possible events that can happen in an experiment, all possible outcomes. Now that is my sample space. So a random variable is just any variable that can take any value within that space. And then we have a discrete random variable is one that takes on a discrete value. That is, it does not take decimal values, it just takes a single particular value. Then a continuous one can take a range of values. So now, like, if I'm talking about a discrete variable between 0 and 2, that means I'm talking about 0, 1, and 2. But now if I'm talking about a discrete value between a continuous variable between 0 and 2, that means I could be talking about 0.01, 0.02, and so on and so forth. Like, it just has a series of values. An example of continuous random variable is weight. An example of a discrete one is age, because age in years can only be 10, 12, and so on. So when we are calculating the probability, that's now we talk about probability mass function. So probability mass function is simply a function that returns the probability of a random variable which is discrete. So if you're calculating the probability of a discrete random variable, that's now you use the probability mass function. But if you are calculating the probability of continuous, probability has its own condition that has to be met. It has to be defined for all x, like every value has to have a probability. Probability lies between 0 and 1. It can never be below 0 or above 1. And then the total probability is of a random variable is 1. Like if you sum all the probabilities, the random variables that you have, it has to give you a 1. An example of probability of a discrete variable is rolling a dice. Like a dice has only 6 sides. So you have a 1/6 probability of getting a 1. You have also a 1/6 probability of getting a 2, all the way to a 1/6 probability of getting a 6. So if you add all of the probabilities, 1/6 plus 1/6 plus 1/6 plus 1/6 is going to give you a 1. And we have the probability density function. As I said, it's just for calculating the continuous variable. The other two characteristics are the same. The only difference is here now, when you're calculating its total, we do integration instead of addition, because we cannot capture all the values if we add. So we need to do integration. So if you integrate, it gives you a 1. Anyone who has a question before I go to cumulative function? Okay, let's continue.
Sorry, can you hear me?
Yes.
The network has thrown me out. I've been struggling with coming in. So, Mike, have you explained the integration network?
I think I lost
I've
you for a
done
minute.
integration before. So I say I'm sorry. I've been struggling. I'm just entering back to join
Yes.
your session. So I don't know if if I've missed a lot, but I just heard you mention integration rather than something else. I don't know if you could just repeat that or just a
Okay,
recap.
so here I'm going to do for you from here. So probability mass function is when you're calculating the probabilities of a discrete variable. That means probability of having a 1, probability of having a 2, like having a single, like it's probability of having a known value, which is single. And then now probability density function is the probability of having any value within a continuous range of values. So for example, a 0.01, a 0.1, a 0.9. So when you're calculating the total probabilities of a discrete value, that means you sum it. You sum the probabilities. But if you're calculating for a continuous variable, you have to integrate it for you to get the total probabilities. I don't know if you get it.
Yes.
Yeah, Mildred, do you mind giving us a real world example on how you can use the probability density functions?
I don't mind. Let me try to. Let's say, for example, we are probability. Let's start with probability mass function. But I already gave the probability mass function.
Yeah, you can even talk about that.
So yeah, if we are tossing a coin, we only have two possibilities, right? Either getting a head or a tail. True or false?
True.
Now, because we only have two options and the total probability is 1, it means for the two of them, it's going to be equal probabilities, which is going to be 0.5 and 0.5. So if I'm calculating the probability of getting ahead, that's when I'm going to use the probability mass function. Like the probability of getting ahead is going to be equal to PMF of head, which is 0.5.
Now, what of the probability density function? Where is it?
Probability density function, I use it when I'm calculating the probability of a continuous variable. Now, for example, let's use weight. The weight, let's say it ranges between 60 and 70, right? So 61, as in between there, I can have so many weights. I can have 60.2, I can have 69.5, all those, right? So because I cannot have a specific value, that's now when I use the probability density function. So I'll integrate, let's say I say, what's the probability of having a weight of 65? So I'll integrate from 60 to 65.
So it is between ranges of something. That's what you're trying to say.
Yeah, it's between ranges of something. Like all you have to know is if you're dealing
what of the cumulative density function?
If you're dealing with a continuous variable, it has to be the probability density function. I have two. We have both for the discrete variable and for the continuous variable. So for the discrete variable, now let's say I want the probability of getting let's use the rolling of a die. So say I have 6 sides, I have 1 all the way to 6. So let's say I want to find the probability of getting at least 3. So because I am looking for a probability of getting at least 3, that means I'm looking for the probability of getting a 1, or a probability of getting a 2, or a probability of getting a 3, right? Are we together up to that example?
You said at least 3.
Yeah, at least 3. So that means it has to be 1, 2 or 3, right? So the cumulative density function now is going to, yes?
At least 3 should be 3 upward. You are describing 3 downward.
Okay. I said at least 3. So that means it has to be 3, 4, and 5 and 6. Sorry, right?
Okay. Yes.
So that means since the probability of getting a 3 is 1/6, the 6 and the probability of getting 6 is also 1/6. So I need to add all of them. So that's now where the cumulative density function comes in. I'm adding for the ones that I want.
Yes.
So is that question on the cumulative density function of a discrete variable?
Thank you, Jabet. I'm still trying to understand the cumulative density function. It's not sinking.
Like cumulative density function, I've only explained for the discrete variable. I've not explained for the continuous variable yet. So what's your question?
I'm still not getting it. Maybe if you could explain it again, kindly.
I wish there was a way I could write. Let's say we're using a dice, right? So we're rolling a die. A die has 6 sides. It has 1, 2, 3, 4, 5, and 6, right?
Yeah.
The probability for each of them is equal, which is 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6, right?
Yes.
So if you're told we need to find the probability of getting at least, let's say at most 3. So that means I'm looking for the probability of getting x less than or equals to 3. Because I'm looking for at most 3. So that means I'll be looking for the probability of getting 1, or the probability of getting 2, or the probability of getting 3.
Okay.
So now I'll have add
1/6.
And I'll add 1/6 plus 1/6 plus 1/6.
Okay, thank you.
That's where this summation will come in.
Thank you, Jabet. That's clear now. I've understood.
Now for continuous variable, now we do an integration. Instead, like we are doing integration, instead of doing the summation, we integrate now from the lowest point, the point that we want. So if I was assuming that this rolling of a die was assuming a continuous variable, and I needed to find at least 3, I'll do an integration from 1 to 3 of 1/6 dx. I don't know if we get each other there.
I guess silence means people are okay. You can continue.
So now we go to the distributions in statistics, and today I'll only talk about the distributions of the discrete variables, and maybe tomorrow Nehemiah will take us through the distribution of the continuous variables. So for the discrete variables, we have three kinds of distributions. We have the binomial distribution, we have the Bernoulli distribution, and then we have the Poisson distribution. So here I'll talk about the binomial distribution. Binomial distribution is simply it takes a series of independents whose outcomes is binary. Like we only have two values of the outcomes. It's either a success or a failure. It's either a head or a tail. It's either true or false. That's the probability. Like it can either rain or not rain. We cannot have an intermediary there. So the probability of obtaining a number is given by this formula over here. It is simply the n is the total number of experiments that we do. K is the number that we are looking for, the probability of that number. Then the probability of one of the variables. 1 minus P is simply the probability of a failure. So P is the probability of success. 1 minus P is the probability of failure. But since we're using Python, this formula has been made easier for us. We only need to provide the variables. We only need to provide n, we provide k, and we provide p. I'm going to use an example of our data set here. And I decided to use 6. And I want us to talk about the probability of having a female customer. Is that a binary probability?
Yes.
Because you can either be yes or no, right?
If you're in Africa.
We're talking about reality of this thing. No matter where you are, if I say we want to find the probability of having a customer, like what's the probability of having a female customer? So, like I can say, I want us to deal with only when we have females only. Like, is there going to be a female customer or not? That's my point here. So, first things first, we have to calculate the value of P, the probability of success. And probability of success is usually the number of successes over the total number of trials. So in our case, the number of successes is the total number of females that attended, which I calculated here using this here, the number of females here. We can maybe see that in another lane of code so that we really know exactly the value. What did I do here? We have 37. So here we yes?
Yes, it's 37.
Here we have 37. And then, sorry. The total length of our variable, the tip, is or not tip sex actually, we're using gender, sorry. Is 100. Why was I getting a probability of 0.36? So when we divide the two, okay, 0.37. When we divide the two now, that's now we get the probability of having a female customer in the restaurant. Are we together up to there?
Yes.
Now, if we assume that this the gender follows a binomial distribution, my question is, what's the probability of observing 40 customers in the restaurant? So here we want to find the probability of observing 40 customers. Our N is 100. That's okay. Our K is 40. The probability we've already calculated up there, which is P. I can just say P. And then now we need to import this function here, binomial, this function from we use it to calculate the probability of having exactly 40, which is binomial dot probability mass function, since it's a discrete variable, and then we provide our parameters, which is K, N, and P. We run, that's our probability here. I don't know, I'm getting a different value. Oh. I don't know if you guys have understood this one here.
Yes.
Now here, next I'm going to be, now here is where the cumulative density function comes in. If you're told now what's the probability of observing at most 40 customers, so the probability of observing at least 40 customers, it means like we can do 1 minus the probability of observing at least 40 customers, right? At least 40 customers, let's say at most 40 customers. Let me use here at most. At most 40 customers, it means from 0 customers to 40 customers, right? Now, since I need to add all of them, like I need to add the probability of having 1 customer plus probability of having 2 customers, all the way to probability of having 40 customers. So instead of doing that manually, we can just use the cumulative density function here. So it just adds for us. Then it gives us the cumulative probability. Any question?
Jabet, I'm trying to relate the calculations with the definition of binomial.
Yeah.
So could you please explain how they relate? Because I'm not understanding.
Yes.
How this is different from any other calculation of probability. What makes it binomial when you are calculating the way we are doing?
What makes it different is because I said we are only looking for the probability of having a female customer. So it's either we have a female customer or we don't have a female customer. Like we only have two outputs, a success or a failure. So it's either we have a customer, a female customer, or we do not have a female customer.
Okay, thank you.
So I wanted to ask also that just to understand this formula, this BINOM stands for binomial. Now the CDF looks like it's native distribution function, but this PMF, I don't understand it, please.
PMF is probability mass function. It's for finding the probability of one value, like probability of observing a 40 only, or a probability of observing one customer only. You get it?
Okay, so the PMF in front of the binomial.pmf, what does that PMF stand for, please?
Probability mass function.
Mass function, okay, thank you. Then the CDF is
Density function.
Yeah, Mildred. So let's say if you want now to interpret whatever you've gotten.
Yeah.
Is it correct to say that the probability of observing 40 female customers is 5.8%?
Of observing 40 female customers. Yeah. Yeah.
Okay.
Is it 5? Yeah, 5. Any more questions?
And what?
Yeah.
Yes, Ibrahim.
That 5.8%. You did that times 100.
Yes.
So that is 1. 2. Oh yeah. Thanks, Ian.
And what happens if you use the CMD?
What do you mean CMD?
It's not CMD, the cumulative. What is it called? Cumulative?
The CDF, cumulative.
Yeah, the CDF.
CDF now you'll be finding for like from the beginning up to where you want it to be. So like now from 0, like from observing no one to observing 40 customers. So that means you'll be adding observing probability of observing 1 customer plus probability of observing 2 customers all the way to 40 customers.
Please just oppose that with the mass function. What are you checking for in the PMF?
Mass function is just one value, like probability of just observing only 40 customers. Like, not the probability, how do I explain it? Like, it's just the probability of observing a single value.
It's clear, thank you. So the cumulative means that you're adding 1 plus 2 plus 3 plus 1 until you get to 40. That's cumulative. You're adding it together. While mass is just for 1. Thank you very much.
Yes.
So you can use cumulative when you want to say, let's say, the probability of observing 40 to 50 customers.
Yes.
So thank you.
Yeah, so I think this Poisson distribution is going to be the last distribution of the day. And then Nehemiah will do the rest tomorrow, the continuous and negative binomial because I don't really get that well. So for Poisson distribution, it's simply the probability of an event occurring within a fixed interval of time or space. So mostly Poisson distribution is applied to Q theory. Like when you're trying to analyze Qs, this is mostly where this is applicable. If we go back to the restaurant example, and then I said coffee, like a restaurant, in a restaurant, like coffee is being served 35 cups per hour. What's the probability of selling exactly 20 cups in 30 minutes? You've understood the scenario?
Yes.
So here,
Yes.
we want to calculate the probability. With the Poisson distribution, let's first import the meaning for Poisson. So for Poisson distribution, we need to provide two variables. That's the K, what we are looking for, which is the probability of selling 20 cups. And then we also need to provide lambda. Lambda is simply the rate. So here is where the challenge is a little. We know our K is 20 cups, right? For lambda, let me just write L to represent lambda. Or let me just write lambda, which is the rate. And here we're being told the coffee, an average rate of 36 cups per hour. What's the probability of selling 20 cups in 30 minutes? So who can tell us what's the lambda here? What's the rate here?
Can I try something?
Yes.
I think the lambda is the mean, and the mean will be 36 because it's the other word of average. Yeah, that could have been the answer, but now it was per hour, but here is 30 minutes, so it has to be divided by 2. Exactly. Yeah.
So that makes 18. And then now we come to calculate the probability. So I'm just going to do Px. It's going to be Poisson dot probability mass function. Then we provide the parameters K and lambda. %. Anyone with a question?
Lambda. I thought lambda is a function.
Lambda is this symbol here.
Okay.
Yeah. Which is supposed to
Anthony.
Yes.
Lambda, Okay. Lambda is just like maybe, okay, for me, I will say it can also be like an icon, the way Chebet is showing you, because we do also have, you see that formula that we looked at for calculating variance.
Yeah.
There's something that looks some funny things, we call it sigma. So these are just like words that are used to call these icons, like lambda, sigma, mu, like that mu meaning mean. Just like Nigerian, sorry, Kiswahili ni ngumu.
English is hard. English is not your first language.
English is not our first language. Not of you to do.
So like this one
Those
here.
things. Yeah, like that one is mu, is known as mu. Then you have the x bar, then you have sigma squared. You see?
Okay.
Yeah, John has. Jebet, Warutere wants to say something.
Jebet, I have a question. For that lambda, how did you come up with 18?
You see here, the question here was 36 cups per hour, right?
Yes.
So that my original number was 36 in 1 hour, which is 60 minutes. But now I want my rate in 30 minutes. So I'll have to divide it by 2.
So you divided the number of cups per hour by 2.
Like you can just do like 36 is equals to 60 minutes or about 30 minutes.
Oh, so you're calculating for the 30 minutes.
Yeah, I'm calculating for the 30
half an
minutes.
hour.
For
So
half
that's
an
why
hour.
you divided 36 cups by 2.
Yes.
So if it was 20 minutes, you would have done for 20 minutes. The number of cups for every 20 minutes.
Yeah, I would have done for every 20 minutes.
Okay, thank you.
Would have been divided by 3.
Okay, yeah, Jebet, is it okay, for example, if I say that we are that the restaurant is serving 18 cups in 30 minutes?
Yeah, that is very
What
much.
is the probability of serving 20 cups?
Yeah, it is exactly the same.
Thank you.
Yeah, so Jebet,
Yes.
is it true to say that lambda is in Poisson distribution is just the average number of events or rate?
Yes, it is.
Thank you.
Sorry, I've just remembered something. You see, these things, lambda, mu, those are just alphabets in Latin. Because if you just Google alphabet in Latin, you'll see all those things from A to Z. Like the way we have,
Is it Latin or Greek?
I'm not sure, but it's something like that. Because the way we have omega, it's A, then omega, alpha and omega. Alpha is A, omega is Z. So those are just those foreign languages, but they are alphabets, in other words. So it's not something to shock you where these things coming from.
It's in Greek.
Yeah, so if there's no further questions, I think I'll end there for the night. Thank you for listening.
Okay. Thank you so much, Jebet. I think they should clap for you. You have just kept our 2 hours, and Jolene was not even like telling us not to speak too much. But we're good people, Jebet and Ibrahim.